How well do you know Git? Learning more about how Git works behind the scenes can help you understand more about Git and file system principles. So do hold tight and get ready for this deep dive into Git, where we take a look inside of the .git folder under the hood, and we'll look at creating our own files inside of Git. So hello and welcome to our glorious playground, a playground where we can lift the covers on Git and really start understanding it. But perhaps the first thing that we need to do is create ourselves a folder for our Git project. So let's go ahead and use the mkdir command, and I'm going to create, should we call it my project? That seems like a good name. We can move into that, and don't forget I can use escape and dot to recall the previous argument, so that takes me into the my project directory. Now it's a brand new directory, so it's not going to have anything inside of it. When we list the contents, of course, we don't see anything but ls-a, and we have those hidden directories, dot and dot dot, the current directory and the parent directory. But let's not waste time and let's initialize our Git repository. So git init, and that can create a repository that we can work with locally. We don't really need a remote repository. We can still use version control just on our local system. But anyway, having created the Git repository, when I look at ls-a now, I have the .git subdirectory. When I look at tree-a, look at this, we can see what it's gone and created for us. So within the .git subdirectory, we have branches, we have hooks, and look at all those sample scripts, info, and objects. And we'll be concentrating on objects because that's where our files are going to be created. But it does need to be said that in general, we're never going to be working inside of the .git directory. This is .git, and it's there to be managed by Git, not by our sticky fingers. But that said, this isn't a production Git repository. It's brand new, so we should be able to play around in this and actually learn how Git works. So first of all, we're going to use the echo command, and we're going to type in hello world. And so long as you type exactly the same as I type, same case, same comma, same spaces, you'll get exactly the same hash as I do. The same text put through a hashing algorithm is going to give you exactly the same hash. So we're going to use git hash-object, and this is going to create an object, a blob object in our system, and we're going to read in from the standard input. And we can see then our hash coming back. Now, when we take a look at the hash represents our file. Doesn't matter how big the file is, it's always going to be producing the same size. So SHA-1 hashes are 160 bits, but they're represented as hexadecimal. And as I say, so long as you put in exactly the same input, you're going to get exactly the same output, exactly the same hash. But you might also say, well, hang on, how come it's 160 bits? Well, it's 160 divided by 4. So 40 hexadecimal bits. Every hexadecimal character is representing 4 binary bits. So we only get to see the 40 characters. We can check this. If I go through and do a word count -c, we can see, well, it shows us 41 characters, but we do have a line feed at the end of our string where we're using echo. So we see then that we have 41 characters. Take out the line feed. That gives us our 40 characters, our hexadecimal representation of the 40 bits. But it won't have done anything in our file system. If I go back and run the tree command, so !t will run the last command that ran with t, we can see that no difference shows. We still don't have any objects below our objects directory. And that's where we're going to be concentrating our focus. So all we've done is read our input and created a SHA-1 hash. If we want to create the object, then just add in the -w for write. So we still see the same output, the same SHA object that was created. And that is now representing our file in our Git file system. When we go through now and look at tree, we can see that we do have our new file object. It's in a directory, the directory 3F, but the 3F and then the corresponding 38-bit make up the file hash. It's just a way of organizing the information in what's called the hash tree. Now, this is a file within the Git file system. It is not a file in our file system, but we can still go through and read information about this. If I use git and cat file, -p, so we can print information about it, so we can print the contents of the file. And I can look at 3F, don't forget to include the directory name, that's part of the hash, but I don't need the whole hash. I only need the first 4 characters. And I can see there that we've got then our content of hello world. So this is looking good. But if I up arrow key now, I could also look at the file type, and it's a blob. So files will be blobs, and we can go through and check its size, and it's 13 bytes. So we can gain a little bit of information of this file, but it's a file, but it's not connected to a tree inside of Git. Yes, it does need to be connected to a tree or a directory entry when we're talking about file systems. It's still only within the Git file system, not our file system, but the Git file system needs a directory or a tree to represent this. So if I go through and run my tree command again, we can see that I just have this one object. I don't have any other objects. And this is my raw file, my blob. But we now need to create a directory entry in our Git file system for this. And this is what is called the tree. So come on, let's go through and start creating our tree and do a little bit of gardening. Now, to make our output just a little bit less verbose, we can look inside of our Git directory and the object subdirectory, so we're only looking inside of the objects directory. This is where we're going to create our tree, but also we need to reference our existing file object. So we can use echo -e to include embedded characters. And the first thing that we're putting in is the file mode. Now we know within Linux, the file mode also includes the file type. So 100 is saying it's a regular file. And then we've got the permission 644, which is the normal permissions for a readable file. The type of directory entry that we're putting in for our tree is that we're linking to a blob, a file within our file system. We then go through and put our 3F, don't forget the start of the hash, and then we can just paste in the rest. We now need the complete hash of the file that we want to put in. We want to separate, though, this with a tab, so /t, and then we'll call our file file1. Now we're just echoing to the screen. It's a good job I did, because I've got my slash the wrong way round. So let's go through and correct that. So / and t. So we can see now the tab being expanded, and we have a tab that is separating our hash from our file name. Now to do the work, we can send this through to git mucktree, and that creates a new object within our Git file system. And this, of course, is a tree object. When I go through and take a look at my objects directory, we can see the original file 3F, but we've new directory now 3D with the hash in that. So we have 2 objects. Of course, one object is going to be my blob. The other object is going to be my tree. When I go through and take a look at git cat file and take a look at printing out the new object, so 3D, and then 13 is all I need to do, we can see it's the data that I sent through. This is then the directory entry table that we have created. But when we look at the type of file this is, or object it is, and we can see that this is a tree object compared to the blob object we were looking at before. So we've created a new entry within our directory entry table or tree by creating a tree object that points to my original file. But everything is still only within the Git file system. If I use git read tree and then start reading that tree object back in, so I can use escape and dot to bring back the 3D13, that's now added it to my file system. And we can see now that I get the little X, so I can look at git status, and we can see there that I have a file. We've not known about this file before, so it thinks it's a deleted file. Now, one way to be able to restore this is using git restore, but we also have another way where we can check out from our staging area. So if I use git checkout minus index and minus a, so everything from our index, we only have the one file in our index, then it's acting now as a new file in my file system. I can list my file system and I can see file 1, so it's properly part of my file system now. I can use git add and the whole directory, and then my git commit, and of course a perfectly formed commit message. So my file, that really explains what's going on, doesn't it? And hit enter, and now we're back into a clean Git repository with our file created, but having done it through the back end. So we've been able to take a look at our git hash object command to be able to go through and create files or blobs within our Git file system. Moving on from that, we could use git and cat dash file. With this then we could go through and look at the contents of a file, the type and its size. The type of file we would be looking at would be a blob for our ordinary files. To create a directory entry in Git, we use git mktree, creating a tree object in Git. Having created our tree with git mktree, we can go through and use git read tree to be able to put that into our staging area. And to move it back into our working file system, we can use git checkout dash index.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.